So I'm Tim. I'm a developer attached to the Bitbucket team at Atlassian, where I've been for about 10 years. I spent the last 7 or 8 of those working on our Git-based tools, Bitbucket, Bitbucket Server, SourceTree, and Jira's version control integration. But today, I'm actually going to be talking about a little-known subsystem of Git called aliasing. Now, how many people here have written a Git alias before? Oh, brilliant. It's like most of the audience. I can go home. Okay, so the first few slides may be a little tedious for you then. But basically, creating a Git alias is a way to create a shortcut for a Git command. Now, there isn't an explicit alias command in Git. Instead, you have to use the git config command to bind an alias name to a command string, which will be invoked when you run that alias. So one common use case for aliasing is to bind commands or Git subcommands to shorter strings. So something like git CI for commit or git ST for status. Now this is great, saves you a few keystrokes, makes Git feel a little bit more like Subversion. But at the end of the day, all it does is save you a tiny bit of time. But aliasing actually solves a huge problem that the Git open source project has. Now, Git has huge velocity. There were 5 major releases last year, and each release had hundreds of features, or hundreds of improvements. If you go and read through the release notes, it's incredible how much stuff this team ships in a relatively short amount of time. But Git also has a problem. It has ironclad backwards compatibility guarantees, which is awesome for tool vendors like ourselves, because it means that we don't have to rush out critical patches every time a new release of Git lands in order to make sure that our products keep working. And it's great for users as well, because it means that the core fundamental workings of Git don't change every time you upgrade, which is great if you have to upgrade 5 times a year. But this huge velocity and backwards compatibility come to a bit of a paradox. How do you ship hundreds of improvements to a command line tool without breaking backwards compatibility? Well, with Git, you've got a few different options. You can introduce new subcommands, you can create new options to use in conjunction with those commands, or you can create new config properties. And Git uses a combination of all 3 of these things in order to ship new features. The downside of this is that Git now has hundreds of commands that you can use, thousands of options, and thousands of config properties to customize the behavior of Git. Now, people often complain, as some of the speakers earlier, that the Git man pages are hard to navigate. And I actually think some of the terminology is a little bit confusing and obtuse, but if you read through the Git glossary, you realize that the Git man pages are actually extremely well written and structured. The only problem is they're so verbose because they have to document all of these different tweaks that you can make to the Git commands when you run them. So take, for example, the git stash command, which Santiago spoke about at length this morning. Now, git stash is a handy tool that lets you squirrel away changes so you can go and work on something else. And if you've made some changes to an existing file that's already tracked by Git, then it works fine. You run git status after you run stash, and it shows that you've got a clean working directory so you can switch context and work on something else. And then you can reapply those changes later on. However, for novice Git users, or myself up until about a week ago, if you create a new file in your working copy, which seems like a fairly innocuous operation, and then you run git stash, stash won't actually do anything. And this is because, the change that you've made by creating a new file is creating an untracked file that Git doesn't actually consider when it runs stash in its vanilla mode. The reason for this is that Git sees changes in your work tree in one of 4 fundamentally separate states. They can be changes to a tracked file that are either unstaged or staged. They can be changes to an untracked file, or basically the creation of a new file, or they can be changes to an ignored file that you've explicitly told Git not to care about. So git stash, run in its vanilla mode, will only operate on unstaged and staged changes to files that are already tracked. So a lot of developers, when they're first coming to grips with Git, will overcome this deficiency by adding all of their changes to the index and then running git stash. But this is a bit of a hack because it means that your index kind of gets messed with, and when you pop or apply your stash later on, then you don't quite have the true state of where you want it to be as a work in progress. So the actual correct way to do this is to use the include untracked flag, which actually stashes your untracked changes as a separate area in your stash, and then you can reapply those correctly later on. So you've got to kind of keep in your mind that there's two different ways of running stash, either stash or stash include untracked. Now, that's not too hard to remember. But then while perusing the Git man pages, I realized that there's also a --all flag you can use as well to include your ignored files as part of your stash. Now, this is fantastic because it means that you can fully switch context. So if you've ignored build artifacts and log files, they will come along into your stash as well. And you can pull those back out of your stash with stash pop rather than having to regenerate those again from your source. But there's also another flag called keep index. And this actually pares down what's stashed and only stashes changes that haven't yet been added to your index. So this is great if you want to commit just some of your changes and save the rest of your work tree for later. So now we've got a bunch of different options that are slightly harder to remember, at least for me. It's not that they're named badly. They do exactly what they say they do, but I still find myself going back to the man pages or Googling when I need to figure out how to do one of these things. So to solve this, I've created a series of Git aliases that do basically squirrel away different bits of my work tree. Now I find this much easier to remember. If I want to just stash unstayed changes in my work tree to tracked files, I just remember that it's git stash with a Kiwi accent. But if I want to stash everything and revert back to basically what my repository looked like when I cloned it, then I do a git stash! And I have a clean work tree just to go and reproduce problems in production or start a new feature branch. So I hope I've illustrated that, creating aliases doesn't just save you keystrokes. It can also be a way to encapsulate the various options that you might want to use as part of your regular Git workflow in your commands. But as I'll show you in the next few slides, you can also use some advanced aliasing techniques to chain together different Git commands, and even Git commands with other Unix tools like grep and, like grep. I cut a couple of examples, unfortunately, to do some cool stuff. And then the other cool thing about aliases is they're inherently shareable. So you can use Git as well to share these aliases with the rest of your team or the general public. So when you create an alias using git config, it actually gets stored in your global Git configuration, usually sitting at the root of your user directory. And by default, it's just stored as the subcommand and options that get passed to the Git binary when you invoke the alias. But you can actually create slightly more complicated aliases that chain different commands together. So this is an example of an alias called which. I tried to chase down where this alias originally came from. I didn't write it. Someone on my team had it sitting in their git config file. But I don't quite know who to attribute this to. But basically what it does is it searches the contents of it searches the names of your branches and then outputs them. So it's just basically piping the output of git branch to grep. Now Git's aliasing system supports parameters. So anything that you tack onto the end of your alias invocation gets passed to the underlying alias command string. So for example, if I was looking for a branch related to a Jira issue that I'm working on, I could use this to try and track down that branch. So the way that this alias works is that we've prefixed it with a bang. And that's basically telling Git, rather than pass the string to Git to evaluate, instead drop out to my shell and get it to evaluate the string instead. And that means that we can use things like arguments, you can use positional arguments, which we'll look at in a second, and you can also use pipes and other non-Git binaries as part of our toolchain. So let's extend that which alias with another one called lucky. Now, this alias, get lucky, is actually building on top of our which alias by passing the output of which to git checkout. So it's basically emulating the I'm feeling lucky functionality on Google. So instead of just searching for branches, it's actually going to check out the first one that it finds. Now this is using positional parameters or positional arguments. So we're actually evaluating $1 using shell or bash syntax and passing that into the git checkout command. Now this doesn't work as I've written it here because although Git does evaluate $1 correctly, it also appends the arguments to the end of the command string. So we'd end up with something that looks like git checkout Jira 7, which is invalid syntax for the git checkout command. So if you're going to write an alias that uses positional parameters like this, then you actually need to wrap it in single quotes, so Git doesn't evaluate it, and then pass it to your shell alongside with a dash at the end, so the arguments get passed through, and your shell will evaluate it for you. Don't worry too much about remembering why this is a problem. Just remember that if you need to use parameters, wrap it in single quotes, pass it to shell, and you'll be fine. So it's not just about using arguments explicitly supplied by the user. You can also use environment variables as well. So this is an alias called Git-standup. How many people have a stand-up meeting once a day? About the same number of people, almost everybody. So what this does is it gives me a prompt for what I'm going to say to the rest of my team at stand-up by showing me all the commits that I've created on any branch. That's what the all flag does for log. By the current user, which is me. So it actually tests the author string associated with each commit to make sure it contains my username. And then it's using the relative datetime supported by Git, which is actually a fascinating topic in itself. It has some really sophisticated datetime parsing. So it's going to show any commits that I've created since last time we had stand-up. And then it's mangling, well, not mangling, it's truncating the format of the output to only show me the subject line of my commit message, which is the first line. So this works great, and the output looks a little bit like this. So I have a nice human parsable output to share with my team. But I decided you could actually automate this further with a lazy-standup alias that pipes the output of git-standup to a speech synthesis command, like say on OS X. So this works great if you're a remote worker and you have SSH access to like a machine somewhere in your team area that has speakers. For example, your team's wallboard. And then you have this ghostly, disembodied voice telling everyone at stand-up what Tim did yesterday. So that's basically all you need to know about building aliases. Remember the bang syntax, remember the fact you use environment variables, and it works. So now you've got a rough idea of how to do it. I want to share with you some of the more powerful Git aliases that we've cooked up at Atlassian to do some fun stuff. And the first alias that I'm going to show you is actually a little bit anti-GitHub and anti-Bitbucket and anti-GitLab. And the reason for this is that Git hosting providers like us actually are in have a bit of tension with us in the Git open source project, because Git is a distributed version control system, and we're trying to get you to centralize all of your repositories on our services, which is fantastic, as long as those services don't go down. Now, Bitbucket had 99.96% availability over the last quarter, which means that for 53 minutes you weren't able to push and pull to your repositories, which sounds great until you're stuck in the middle of those 53 minutes trying to get code to someone else's machine. Now, Git, being a distributed version control system, actually has a built-in Git server that you can use called the Git daemon. Now, like many Git commands, the Git daemon has a set of somewhat unintuitive options, so I always end up kind of having to Google how to use it if I want to invoke it. Actually, and a little aside, if you find yourself repeatedly Googling for Git commands, that's a really good opportunity to turn that into an alias so you don't have to go and search for that later on. Now, when you run the Git daemon, it starts serving your local repository over the Git default port, which is 9418. And by default, it's pretty rudimentary. It's read-only. You can actually make it writable, but that's not a great idea because it's also unauthenticated. But anyone who has access to that port on your machine can now clone your repository. Unfortunately, if you have remote team workers, or depending on your local network setup, you may not actually be able to access your colleague's port 9418. So I've built a little alias that works around this problem using a tool called ngrok. Does anyone use ngrok? Fantastic. Oh, brilliant. OK, maybe a third of the audience. For the rest of you, ngrok is a little tool for creating a secure tunnel from a local port on your machine to a public website as a subdomain under ngrok.io or ngrok.com. And basically, you can copy and paste that URL and share it with a teammate, and they can access that port as if they had direct access to your machine. So it's great if you're a web application developer and you're trying to share code with clients or anyone else who wants to access your web server. Now, they actually also support arbitrary TCP tunneling. So Git ngrok actually starts up a local Git daemon and then starts up ngrok and proxies your local repository out to the public internet via the Git protocol. So you can just copy and paste that URL, send it to someone, and they can clone your work. So it feels kind of like I'm trying to put Bitbucket out of business by showing you this. But it's a good way to share code in a pinch. Now, you do have the same restrictions in that by default it's going to be read-only, and it is also unauthenticated. So although these URLs aren't listed anywhere except your local machine, it's a pretty easy URL to guess if you're doing some port scanning. I think ngrok does have a whitelisting feature that lets you, basically prevent unexpected IPs from accessing it. So to show you how this works under the hood, basically instead of wrapping the command in those single quotes and passing it off to shell, we're going to use an anonymous bash function instead. And this is kind of a nice way to write multi-line aliases. and we're calling our git serve alias that we looked on the other slide to invoke the git daemon. And then we're using a single ampersand to fork another process, ngrok, to start it up in TCP mode to proxy that git port out. And then we have a couple of other niceties to hit the local ngrok API. So I only just found out about this thing, but ngrok actually spins up a little application server locally that you can query via REST to find information about your local tunnels. And then so it grabs the public URL of that tunnel and prints that out on the command line. To do this, I'm actually using another little tool called JQ, which is great if you're building aliases that need to interact with other services that have REST APIs. It's basically like a little command line parsing and assembling tool for JSON that I highly recommend. Now, you might be looking at this slide, and you'd be forgiven for thinking that this isn't actually a talk about Git aliasing. This guy's just giving me a tutorial on bash programming, which is definitely not what I signed up for. And you're absolutely right. At the end of the day, these aliases are just bash scripts that are invoked via the Git binary. So you get this sort of philosophical question about when should I create an alias in Git and when should I create an alias in bash? And really, it's all about context and namespacing. To invoke one of these aliases, you have to prefix it with Git. So if you're using bash autocompletion, and you probably are, then it's really, which fully works with Git alias as well, by the way, then this is a really handy way to make sure that you pare down the number of commands when you autocomplete. So basically, my philosophy is use Git aliases for Git operations and bash aliases for anything else. And the corollary of that is, if it doesn't use a Git command or it doesn't touch the .git directory, then it probably shouldn't be a Git alias. Sorry, jumped forward a little bit too fast. But another cool use for Git aliases is that you can use them to interact with services that enhance the Git experience or build on top of Git, like Bitbucket. Now, if you're a Bitbucket user, you may have noticed in the left-hand nav, for the last few months, you've had this little pipelines link. And if your team's enabled it, you will have started seeing build statuses showing up in the right-hand side, because pipelines is our new CI/CD tool built directly into Bitbucket. Now, we built CI/CD in Bitbucket as pipelines because we wanted to help teams with Bitbucket with their DevOps tool chains. We wanted to make it ridiculously simple to start getting your code tested and deployed in an easy manner. And basically, it's integrated right into the Bitbucket UX, so you can see all your build results and on pull requests and branches, and actually inspect your logs and jump back and forth between source and builds really easily. Now, it turns out that Git aliases are a really cool way to interact with CI and CD servers. Now, the way that Bitbucket Pipelines is configured is that you create a little YAML file in the root of your repository, specify a Docker image as your build environment, and then create some steps that are run every time you push changes to the server. We also have this feature where, in a less sort of continuous manner, you can specify custom builds that do things like ad hoc deployments if you're not quite ready for continuous deployment, or run heavyweight jobs that you want to do on you don't want to do on every commit, like static analysis or publishing documentation or any of those other things that you have scripted up but maybe don't want to run every commit. Now, Bitbucket has a fairly simple UI for triggering these deployments. You can click from a commit and hit the deploy button. But since a lot of the time, when I'm thinking about doing one of these jobs, like deployment, I'm actually in my Git terminal, I thought it'd be fun to write an alias that hits the pipeline REST API to deploy a commit for me. Now, this has a couple of advantages over doing it via the Bitbucket UI as well. So for example, I can use Git pipeline to deploy a specific commit, or I can use it to deploy a specific tag, or deploy the documentation for a specific tag, or I can run static analysis against a feature branch that I'm currently working on. Now, a lot of these tools that you might want to integrate Git with don't necessarily have the full DAG when they're working with building. Now, when they're working on servicing your REST requests. Now, Bitbucket Pipelines does, but in some cases, you might actually have to turn these commit issues, so it's basically a shorthand for a commit or something that can be dereferenced to a particular commit, into a commit SHA. So there's a tool that Git ships with called rev-parse, which is kind of used under the hood for turning what you've provided at the command line into a SHA-1, which can be used by the rest of Git. And it's, so this can do things like translate short SHAs, translate feature branches, or any other ref like tags or even annotated tags, things like reflog short names. So a couple of people have made parsing references to the reflog, but basically Git keeps a log of the state of every branch that you've had locally, and then records how that's changed over time. And you can actually use a reflog short name to say, hey, tell me what the value of my master branch was yesterday. And rev-parse will turn that into a commit ID, which you can then pass onto a service. You can also do things like ancestry references as well to describe a commit that's related to another commit. And all of these will all just output that SHA-1 hash of the commit. Now, Git also has a sister command called rev-list, which does much the same thing in terms of translating SHA-1s, but it'll also show you every commit in that range. So whether you're using double dot syntax or triple dot syntax, basically anything you can pass to git log, you can pass to rev-list to get a list of commits that traverse your DAG. We use this pretty heavily behind the scenes in Bitbucket for a number of different operations. But I found I actually use this to create a second script called pipelines that will trigger a particular job, or a particular pipeline rather, for a series of commits. Now you might wonder why you would possibly want to run the same pipeline against a series of commits. So let's just pause that thought there for a second, and let me talk about a little scenario that you might find yourself in. Imagine you're a developer, and you pulled master at the beginning of the day, and then you created some new commits, and you want to push them to the server. Now you go and check Bitbucket Pipelines, and then you see that the current tip of master is passing the tests, so you're safe to push. We're not doing feature branching for simplicity here. We're just committing straight to master. So when we push, we wait a couple of minutes, and then we get a notification from Bitbucket Pipelines saying that our latest build has failed. Now, we've got a bit of a problem because there's 5 potential commits here that introduce that failing change. And wouldn't it be nice if we could do some sort of binary search over our history and find out which one caused the problem? Now, Git actually has a built-in command that does that. Does anyone know what I'm talking about? Bisect, yes, git bisect. That's right. So you can actually run git bisect, pass it the failing commit hash, so that would basically be the tip of master as it is on the server, and then pass it the last known green build, which is actually the tip from before we pushed. For bonus points, can anyone tell me what the big O complexity is of a binary search? Log n, very nice. So this is basically a complexity of log n. So our expected time to find the failing test is however long it takes for our test to run times log n, which is the number of commits, so log 5. So that's great, and that's actually an incredibly efficient way in order to pare down and figure out where this problem was introduced. But it turns out we can brute force our tests using Git pipelines and run the tests for every single commit in that range simultaneously and find our failing test in T, which is the length of the test run. Now, of course, this is horrifically inefficient in terms of being the little CPUs in AWS that are crunching through our code. But from the perspective of the developer sitting there, this is actually great. I've saved myself log n attempts at attempting to find that broken test. And we can use that same reflog short name syntax that I was talking about before to specify exactly the commits, the commit range from the commits that we just pushed before and the commits that were at the tip of master beforehand. And it will come back and tell us exactly which commit broke those tests. So yes, this is horrific in terms of CPU time. But in terms of actually paying the costs for CPU time versus paying developer salaries to sit there and wait for bisect to complete, this is actually a pretty cost-benefit effective way to find a broken test. So the pipeline alias is interesting. So to try and make it sort of production-ish, I've thrown in some environment validation to make sure you've set your Bitbucket credentials, and some dependency checks to make sure you've got that JQ tool installed locally. And then we've got some horrific embedded JSON, which is a payload to the Bitbucket Pipelines API. And writing these scripts inline in my Git config had a bit of a strange effect on me. It was about when I was trying to figure out whether I needed 3 or 4 or 5 backslashes to escape those JSON quotes that I started to regret submitting Git Aliases as a topic to Git Merge. But then I realized that you don't actually have to write aliases as aliases. In fact, you can extend Git by creating scripts. So as long as you create a script that is prefixed with the word git dash, and you can write it in any language, doesn't have to be Bash, it could be Node or Python or Ruby or whatever you like, really, whatever you use for scripting, and then put that on your path and make it executable, then Git will actually find it for you when you invoke git space script name. So this is a much more maintainable way to write scripts. And to illustrate this, I want to show you one last little tool that I built for this talk. Now, I want you to tell me if you can see anything strange about this screenshot, other than the emojis and the commit messages. Now, this is a screenshot from Bitbucket. It has been cropped a little bit, but it has not otherwise been tampered with. Can anyone see anything a bit weird about this? Yes, the SHA-1s look a bit strange. Now, this is very strange because, as I'm sure most of you are aware, the SHA-1 commit IDs are an actual SHA-1 hash of the contents of that commit. And yet, here we have these monotonically increasing commit numbers throughout our commit messages, which is very strange indeed because SHA-1 is evenly distributed, well, a well-distributed hash to be secure. It actually comes down to those emojis. We built another little tool called Git Sham that takes a regular expression and then it rewrites the latest commit message from the tip commit of your repository by appending 3 different emojis to it in random order. And then it keeps doing that until it finds a SHA-1 that matches the regular expression that you passed in. So this is fantastic. If you so for example, the Bitbucket Server 4.1.4 release coming up, I thought it might be nice to celebrate with a little custom SHA that started with 4.1.4. Now, this is a bit weird philosophically because Git is content addressable, but now the SHA-1 hash sort of represents that content as well. It's a bit of a mindfuck. Anyway, this is horrific. Do not use this under any circumstances. But writing this tool, despite how evil it is, was much more pleasant because I just wrote it as a little script, put it on my path, had nice syntax highlighting from my IDE, also a giant array of emojis. I actually couldn't figure out a way, like there's no sort of contiguous range in Unicode of emojis that you can use, so it's just like a hard-coded array, at least that I could figure out. And this is really good because brute forcing SHAs is horrifically expensive. So I could actually, basically, you're running like a little small-scale Bitcoin mining operation every time you run this command. So it means I could re-implement this in C and then just have that command, that binary sitting on my path, and as long as it's executable, Git will find it and run for us. Now, I mentioned before that sharing aliases is really simple, and it is. So I've put all of the aliases I spoke about today up in this Bitbucket repository. There's a short link on the next slide, so don't worry about writing that down. And then you can actually include this, if you clone it locally, using a git config include. So if you put an include section with the path property, then it will actually include that config file wholesale inside your git config. Now, a little obvious word of warning, don't go including random stuff in your git config from the internet. If you, I mean, you can totally trust me though. If you, like running a Git alias is basically the same as you typing in the command, so it is quite dangerous. And there are other potentially sensitive properties that might sit inside your Git config that will be included as well. So Git aliases are a lot more than just saving time, although they are handy for saving those keystrokes. You can use them to encapsulate all sorts of weird and wonderful options that you hopefully use as part of your Git workflow and save a lot of time, not just in terms of the keystrokes, but in terms of not Googling for stuff all the time. You can also use it to chain commands with other awesome Unix tools and other binaries of your own devising to build some really cool stuff. And then it's really easy to share these tools with the rest of your team using Git. So thank you very much for your time. You can go check out the aliases at bit.ly/gitalias. ngrok and JQ are now indispensable parts of my workflow. So if you're a web developer, absolutely check out ngrok. It's awesome. And JQ is a lot of fun too. You can check out Git Sham. Don't do it. That's a terrible thing to do for your team. And if you're interested in checking out pipelines, you can see it at bitbucket.org. It's enabled for all accounts by default. Thank you very much for your time.